This screencast is going to focus on absolute value. What is it? How do we evaluate expressions involving it? And how do we solve equations in situations that involve absolute value? Let's take a look at the concept of absolute value. So absolute value is the distance something is from a reference point or zero on the number line. It could be in the positive direction or the negative direction. As a symbol, we use what are called absolute value bars. They are vertical bars around the quantity that we are defining the absolute value of. So graphically, this would be a distance of 5 from 0 on the number line. So a quantity 5 or negative 5 would have an absolute value of 5 because both 5 and negative 5 are 5 units from 0 on the number line. So here's an example. Suppose you're on Illinois 267, 5 miles from school. Your absolute value, your distance from school is 5 miles. Well, where are you? Well, you could be 5 miles north up in Medora. Or you could be 5 miles south of the school in Brighton. So that's just kind of a quick review to the concept of absolute value. Let's evaluate an expression that has absolute value involved in it. So we have the expression 2.7 plus the absolute value of 6 minus 2x if x is equal to 4. So what we're going to do is substitute a 4 in everywhere we see an x. Okay, so we have now 2.7 plus the absolute value of the quantity 6 minus 2 times 4. And of course we're going to use the order of operations here, so we're going to take care of the grouping first and then the multiplication and division left to right. So we get 6 minus 2 times 4, which is 6 minus 8, all within the grouping of the absolute value. So that gives us 2.7 plus the absolute value of negative 2. But remember, absolute value is the distance from 0 on the number line. So the absolute value of negative 2 is actually positive 2. So we get 2.7 plus 2, and the answer is 4.7. Let's look at solving an absolute value equation. So here we have the absolute value of y plus 3 is equal to 8. And so we're going to find the value of y that makes this a true statement. Generally with absolute value equations, there are 2 solutions. And so what we have to do with absolute value problems is break it up into 2 situations. Just like we could have been 5 miles north of the school, we could have been 5 miles south of the school. Typically in absolute value, we have 2 situations. So in this case, that y plus 3 is equal to 8. So we'll go ahead and solve that all the way through. If y plus 3 is equal to 8, we can use the subtraction property of equality to take 3 away from both sides. Y plus 3 minus 3 is equal to 8 minus 3 from a previous screencast. And so that gives us, in that first case, a value that y equals 5. But it could be that y plus 3 is equal to negative 8. That's what this a equals negative b is. So we're going to write y plus 3 equals negative 8. Remember, typically in absolute value equations, there are 2 cases that we must consider. So if y plus 3 is equal to negative 8, we're going to use the subtraction property of equality again, subtracting 3 from both sides to give us, in this particular case, that y could also be equal to negative 11. So there are 2 possible solutions to the equation. So once we check our work, we place in that solution of 5. We get the absolute value of 5 plus 3, which is the absolute value of 8, which is 8. But similarly, if we were to put in a negative 11 for y, we get the absolute value of negative 11 plus 3, which is the absolute value of negative 8, which is also 8. So the solution set, written in set notation, is brackets negative 11 comma 5. These are 2 individual solutions to this absolute value equation. It is possible in some cases to get no solution as an answer. So if we take this example, the absolute value of 6 minus 4t plus 5 is equal to 0. We're going to try to isolate the absolute value first. So what we're going to use is the subtraction property of equality to subtract 5 from both sides. And so what that gives us is the absolute value of 6 minus 4t is equal to negative 5. Well, absolute value is a distance. Geometrically, it is never negative. So this can never be true. There is no value of t that will make this true because the absolute value can never be a negative. So the solution set is the empty set, empty or null set. There are no solutions to this equation. Let's take a bit more complex case where we have an absolute value and a more complex expression on the other side. So we have the absolute value of a plus y equals 2y minus 3. So we're going to look at the case where the absolute value is equal to b. So a plus y could equal 2y minus 3. And we'll go ahead and work that case out. We're going to try to bring the y's together and put the constants on the other side. So the first thing we're going to do is go ahead and subtract a y from both sides. Once we do that, 8 plus y minus y just gives us 8. 2y minus y gives us y. So we get 8 equals y minus 3. Our next step is going to use the addition property of equality to add 3 to both sides. That gives us that y is equal to 11 in this particular case. We do need to look at the other solutions. Our 8 plus y could equal the negative of 2y minus 3. Now notice that negative sign is in front of the entire thing because 8 plus y could either equal positive quantity 2y minus 3 or it could be negative quantity 2y minus 3. Go ahead and distribute that negative, and so we get negative 2y, and the negative of negative 3 is positive 3. So we rewrite this as 8 plus y equals negative 2y plus 3. That's very similar to multiplying everything on the right side by negative 1 because there's a negative sign there. So our next step is going to be to bring the y's to one side. And we're going to do that by adding 2y using the addition property of equality. Adding 2y to both sides gives us 8 plus 3y equals 3. Finally, we're going to subtract the 8 from both sides. And so when we subtract an 8 from this left side, the 8's cancel out. We do 3 minus 8, we get negative 5. So 3y equals negative 5. Last thing we're going to do is divide both sides by 3 using the division property of equality. And so y, in this case, equals negative 5 over 3. Now, it appears that we have two solutions here, but we always have to test them. So we get the absolute value of 8 plus y equals 2y minus 3. If we test and put in 11 to this, let's see if we have a true statement. We get the absolute value of 19 on the left side equals 19 on the right side. That is a true statement. So y equals 11 checks out. On the other hand, if we check the negative 5/3 out and place a negative 5/3 in for y in both places, we get the absolute value of 19 over 3 equals negative 10 over 3 minus 3. And so the absolute value of 19 over 3 is not equal to negative 19 over 3. So that second solution doesn't check out. Always check your solutions. Therefore, the solution set for this absolute value equation is only the quantity 11. This screencast covered concepts in absolute value, including evaluating expressions and solving absolute value equations.